Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at a very interesting technology that is NATS. So here in this video, we will be looking at how we can implement messaging application using NATS. So here in this video, we will try to use NATS, a modern messaging platform for IoT, edge, and microservices devices to demonstrate messaging modes such as request reply and pubs up. So let us see how we can do that in this video. So coming to my test environment, I am working on Fedora 41 server, wherein I'll be deploying a set of tools related to NAT server and NAT CLI, and we will see how we can leverage those tools to build a basic messaging application using the CLI tools. So before diving into the details of the implementation, let us try to understand what is NATS. So NATS is an open source high performance messaging system. It is a CNCF project that is in incubated state. It is a connectivity technology that powers modern distributed systems. So what exactly is modern distributed system? So in this today's digital system, we have services deployed all over the globe. We have services deployed in multiple cloud environments, on-prem services, and we have services that are deployed on IoT devices or moving moving devices such as cars, smartwatches, and whatnot. So these are all can be considered as components or devices of a modern distributed systems that talk to each other continuously, providing real-time data and services. So a connected technology is basically responsible for addressing, discovering, and exchanging of messages. So all these devices or components that are in the globe or in the digital space, there is one thing common. They all need to have some addresses. They need to discover each other, and they need to exchange messages with each of them. So this diagram or this high level view of what a digital space looks like tells us how the digital world is connected with each other and how the real-time data is getting exchanged between each of them on a continuous basis, and how these data is going to be utilized basically to power some other services and do analysis on that one. So let us see how we can use NATS, which is a modern messaging platform, to get a simple or very basic messaging topology implemented, that is pubs up or request reply. So coming to our procedure, so the first step is we need to download the NATS binary. So as I said, NATS is a very NATS is a messaging platform for modern distributed systems like IoT devices, microservices, or edge devices, wherein we can deploy it with ease. And this NATS binary that we are going to download is very small in size. So it is a lightweight binary that we can deploy it on any devices with which we want to get some data or we want to communicate with that devices. So the NAT server itself has minimum hardware requirements to support small edge devices, but can take advantage of more resources if available. So that's what NAT server is on. So it can be deployed on edge devices with limited resources, or it can be deployed on a high-end server, taking the advantage of the resources that are available for that server. So here, we will install NAT server using the CLI method, wherein we will be downloading the binary and installing it locally as shown below. So this is a command that you can use in order to download the latest binary onto your server. So I'm currently working on a Fedora server wherein we'll be downloading this binary. So I already have that binary downloaded, but let's download it again. That should be fine. So this binary basically is a NATS. It provides the NATS service infrastructure. So we can see that the NATS server binary is downloaded. Now let us see like how we can run that binary. So in the step 2, like we will see like how we can run the NATS server. So the simplest uh, infrastructure or the version of NATS service infrastructure that we can build is a single process of NATS service. And this NATS server binary is highly optimized, very lightweight, and extremely efficient in its resource usage, as I said. So as you can see, it is very small in size, and it can be deployed in any of the devices, as I mentioned. So let us see like how we can run it in a very basic mode, that is just by running the following command. So you can see the NAT service is up and running, and it is listening for the client connections on the following port. So this is all is needed in order to run a NAT server. And this is by the way, this is the very basic setup, and wherein the security is disabled. But we can configure this NAT server with a configuration file, which will help us in configuring the authentication, authorization, or the persistent storage, or the host name or port settings that we want to update. So there are a lot of configuration that we can update or customize with the help of the configuration file. But currently, like we are looking at how we can run it in a basic mode. Now that we have our NATS server running, let us go to our next step, that is step 3, install NATS clients. So basically, like a NATS server can run on any server or any end device, but we need a client tool in order to communicate with those servers. So the client tools is basically with which we will be building our client applications, which will use that NAT server to communicate with each other. So NATS supports different client libraries written in different languages. So approximately there are 40 plus client libraries written in different languages that support NATS. So we can leverage those tools to build our applications using these client libraries to build our messaging application. So here, like we will install NATS CLI to interact with, test, and manage NATS. And we will not be looking at the JetStream, but yeah. So JetStream is basically a layer on top of NATS core infrastructure, which provides us with the persistence capabilities. So we are not going to look at that one in this video, but yes. So JetStream is an additional layer on top of NATS core. So let us install the latest version using the go install. So we'll use this command to install the NATS CLI tool. And first thing, we need to ensure that we need to have go installed on our system. So let me first install go. So I already have this installed on my machine. So Golang is already installed, and now we can use the go install command to basically install the NATS CLI tool. And this is going to create a directory on our server, for which we need to basically export the binary path that we will be taking a look at it. So right now the binary is like download. So this is basically will download the go folder over here, and we can see the bin directory wherein the NATS CLI tool is available. So this path basically we need to export as a variable. So what we will do is we will add this to our path environment variable in the users bash rc script. So as you can see, this we have just added this, updated this path environment variable to also include the Go binary NATS CLI tool under this path. So that is all we need to do. So first we need to install the NAT server. We need to start up that server, and once that is done, we can install the NAT CLI tool, and we can just export the path for that one in our bash RC script. So once that is done, then you can just verify that the NATS version you are able to get the output. Now let us go to our next step, that is step 4, add context. So we have the NATS client installed on our server, but the NATS CLI tool doesn't know like what is the server that it needs to communicate with. So in order to configure our NATS CLI to communicate with the server that we have just launched in our first step, we need to configure the context. So context is basically a configuration that is created for that NATS CLI, so that NATS CLI can use that configuration file in order to communicate with the respective NATS server. So a NATS CLI context is basically a named configuration with the configuration details to communicate with the NATS server. Here we will add the default configuration to communicate with our server locally. So we have launched our server to listen on locally. So like we basically are working on a local setup. So we will add a context name localhost as shown in this command. Let me clear my screen, and now let us run this command, wherein we are adding a context named localhost with the following description. So let us add it, and this is going to add the following configuration. So it basically tries to communicate with the local NATS server on the following localhost and port. And this is the configuration that it will be using for communicating with the server. So here you can see like we have the URL with of the NAT server where it will try to communicate. And let me remove this for now. By default, like you will not get anything. We will not get a username and password because we haven't added it in the command. So I'll just remove it. This was added by me previously, but yeah. So the default file will be looking something like this. So once you have added your context, I clear my screen. So once we have the context added, we can list the available context for our NATS CLI to communicate with the NATS server as shown below. So we will use the NATS context ls. So as you can see, like we have our localhost context added that we can use in order to communicate with the server. Now let us go to our next step, that is step 5. So here, like we have our server ready, we have our client tools installed, and we have configured our client with the configuration that is needed to communicate with the server. Now let us see like how we can build a very basic request reply messaging model using the NATS CLI tools. So this is the high level architecture that we are going to build for this demo. So as you can see, like we have our NAT server at the center. So this is the core part of our infrastructure, and we have so we will be setting up these two components that are publisher and subscriber. So basically in a request reply model, a request so in a digital world, like we have different API services running which provide services to the clients. So these API services that are deployed can be considered as the subscribers, okay, and publishers as the clients who are trying to access that API service. So this is how like you can try to understand this request reply concept. So a client, basically a publisher, sends a request to the service, basically a subscriber. So this service will basically consume that message and it will try to reply to that request. And this reply goes back to the client. So basically it is a response. So or you can call it as a reply. So this is the high level model that we are going to build. But there is one interesting thing about NAT is how these two clients, so the publisher or the requester and the replier, how they are talking to each other. So here comes the concept of subject or subject based messaging. So let us try to understand what that exactly is. So NATS is a subject-based or interest-based messaging system, also known as subject-based messaging system. Basically, a client or like a requester needs to show some interest by subscribing to a particular subject or a subset of subjects on which it's interested in getting messages. So in this case, like this is the client who is interested in getting a service, who is interested in talking to a service named hello.nats underscore service. So basically, a service is known by its name. So this name is basically known as subject. In short, NAT uses the concept of subject-based messaging. You can publish or subscribe to a series of tokens separated by period. So here you can see like we have a service that is NATS underscore service, and this is named as hello.nat service. So if you want to communicate with that service, you need to provide the address or the subject as hello.nat service. So that is how the subject-based messaging happens. So let us try to understand a bit more about what a subject is all about in NATS. So at its simplest, a subject is just a reference of just a string of characters that form a name the publisher and subscriber can use to find each other. Okay, so this is basically a name that the publisher, subscriber, or request or replier need to know in order to communicate with each other. Subject, which is a string of characters, can be further subdivided by a period to form a hierarchy of child subjects. So this is what makes it very interesting in the NATS technology. So let's say, for example, like you have a store in multiple regions and you can define your subject as follows. So let's say you have a store in US, you have a store in US East region, and you have a store in India, and you have a store in India's southern region. So how we can communicate with each of this uh, region or place is with the subject name. So store.us, it is going to be communicating with all the regions in the US, and store.us.east is going to communicate with only the eastern region in that eastern part of that US region. So similarly, store.india, if you are providing this as a subject, it is going to talk with all the regions in India. But if you want to specifically talk with the southern region of India, you need to provide the complete subject as in this example. And these whatever these words that you see, they are called as tokens. They are separated by a period. Now that we have understood about the subject messaging system, let us now create a very simple NAT service named NAT service, which will reply with, "Hey, I am a service running on NATS." So let us see like how we can run it. So we will use the CLI tool, that is NATS, in order to create our service first. So let us create our service. So you can see like this is the NATS CLI tool that we are using to create a service with the command reply, and we are going to provide our service name or the subject as hello.nats underscore service. And whenever there is a request is received by this service, this is going to send a response or reply with the following message. So you can see the service has started listening, and it is a part of the following group. Now let us try to let us now send a request to our service with the subject hello.nats underscore service. So right now, as you can see, as soon as the request is sent, our subject based service is sent to our subject based service. So we have received a response which is sent by our service. So let us see how that happens. So this is the command that we need to run basically in order to send a request to our service. Let me open another shell. And here we will try to request from that service. So you can see it has sent a request to the following service, and it has received a response with the within the following time period, and this is the response that we have received. And if you try to look at the service console, you will see received on subject hello.nats underscore service. So this is what you will see whenever a message is sent on that service. So let us try to send another request, another two requests. So you'll see there are two entries that have been received on the console on the service side. So this is a very basic service that we can build using the NATS CLI tool and the NATS server. And even you can create a group such as queue, wherein we can club all the subscribers or all the responders in a particular group, so that whenever a request is sent, it is served by only one particular subscriber. So this is like a load balancer kind of activity, wherein we want a request to be served by only one particular responder or replier, rather than it getting a reply from all the subscribers. So that is a bit of advanced topic which we are not going to look at right now, because we are trying to just understand how we can leverage NATS, which is a very lightweight binary or lightweight messaging messaging software that we can use in our edge or IoT devices or microservices. So now we have seen how we can send a request, and we have seen how we receive that response from our service, and how the logging happens on both sides. We can we can verify the console logs of our service, so that we have already done. And as I said, you can even send n number of requests to the service. So let's say if you want to send 10 requests to the service, we can use the count option as shown below. So let us see. So instead of sending manual requests, let us try to send 10 requests. And you can see all the 10 requests have been submitted, and we are seeing the response has been the following service has responded to those requests. And even so now that we have understood about the request reply model, let us try to understand about the PubSub model. So for this, let us go to our next step, that is step 6, create a publish subscriber messaging model. So here is the high-level architecture of the PubSub flow model. So this is our NATS server with the NATS core feature running, and here is the publisher. Basically, this publisher will publish messages on the following subject. So we can understand it in this way. So let us say we have a newsletter that is publishing topics on Python, and there are interested parties that want to like get all those articles on that newsletter related to Python. So they are called as subscribers. So what is common in between both the parties, the publishers who are publishing those newsletters and the subscribers who are consuming those newsletters? They need to know what is the subject, like what is the interesting subject they are uh, willing to have information on. So this is what the subject is all about. So here, like, subject is hello.python. So whenever there is a publishing happens on that particular subject, all the subscribers that are listening for that subject, they will receive all the messages or all the newsletters related to that subject. So this is what the publish subscribe topologies are about. So let us create a subscriber who is interested in the content related to Python program. So for that, like, we will use the NATS sub command. So let us kill this, and here, like, we will run the NATS sub to launch our subscriber. So this subscriber is going to listen for any newsletter or any article related to hello.python. So let us see, run it, and you can see it is subscribing on hello.python. Now let us publish some content on the subject hello.python using the following command. So we will use nats pub. Let us go to our next console shell. Let me clear my screen, and here, like, we will use nats pub to publish on the following some content on the following subject. So this is the content that we are going to publish. We are here to publish content on Python. So once you run this, you will see it has published that content to the following subject, and this content should be consumed by the following subscriber which we have launched. So you can see we are here to publish content. Message has been received by the following subscriber. So you can have multiple subscribers like this. So this is a model of wherein we have fan out model, wherein there is one publisher and multiple subscribers. Or we can create a fan in model wherein we have multiple publishers and single subscriber. So we have checked the subscriber console, wherein we have seen receiving the content published on the channel. So this is the content that we have seen. And as I said, like, we can create a fan out pattern with multiple subscribers and single publisher also, or fan in pattern with one subscriber and multiple publishers also. That is what NATS is all about. So this, whatever feature topologies or the messaging models that we have currently built, we have used only the NATS core feature. So one thing, if you notice, the NATS core feature doesn't provide is persistence. So persistence is all about, like, how we can persist those messages that are published, which can be consumed by the subscriber. So that is actually missing over here. So let's say if the subscriber is not connected and the publisher has published those messages will be lost, and there won't be anything that would be received by the subscriber, even if they are coming up later on. So that is where the persistence topics comes into picture, and this persistence is provided by the NATS jetstream feature. So NATS jetstream is basically a layer on top of NATS core that provides persistence of the messages in the form of streams that we can create using the key value object store or file based stores also. So that is going to be a bit of more advanced topic that we may look in another video. But for right now, like, this is what I wanted to show you in this video, how we can leverage NATS, which is a modern messaging platform, to build our modern distributed applications with all the APIs, services, and with publisher subscriber topologies. Okay, so I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.